Good morning. It's Friday, March 20th. This is Miss McKibben, and we are going to be looking at solving absolute value equations. As you know, absolute value means the distance from zero on a number line. When we solve an equation with absolute value, there are two conditions to consider. Let's consider the absolute value equation of x is equal to 3. Well, if we're on a number line and here's 0, we want to know what number is 3 units away from 0. Well, positive 3 would be 3 units away from 0, and negative 3 would be 3 units away from 0. So this x value inside these absolute value bars really could be either positive 3 or negative 3. Both of these values are 3 units away from 0. The steps to solving an absolute value equation will be to isolate the absolute value expression. Get whatever is inside of the absolute value bars alone. So if I had an absolute value equation, x plus 3 minus 5 equals 12, let's say. I'm going to want to isolate this absolute value right here. So get that by itself first. Add 5 to both sides. And now I have the absolute value isolated on the left. Absolute value of x plus 3 equals 17. Next, I'm going to set that absolute value expression equal to the positive and negative value of the number shown. So I'm going to break it apart, and I'm going to take this x plus 3 and set it equal to positive 17, and I'm going to set it equal to negative 17. And then what you have now is two separate equations. So truly, every one absolute value equation is going to be two separate equations that you have to solve. On the left here, if I subtract 3 and subtract 3, I get that x is equal to 14. On the right, if I subtract 3 and subtract 3, I get that x is equal to negative 20. So my two solutions for that first equation, that one equation, would be both x equals 14 and x equals negative 20. Both numbers would make the equation true. Let's look at some more examples. Like any equations, you can have very simple equations or more complex equations. Right here on number 1, we've got the absolute value of x equals 6. The absolute value is already by itself. There's nothing to do to isolate it, so I'm just going to set it equal to the positive 6 and set it equal to the negative 6. And those are my two solutions. There's no solving involved. On number 2 here, we've got the absolute value of 4x equals 12. The absolute value is already isolated, so I'm going to set the inside of the absolute value bars 4x equals positive 12 and 4x equals negative 12. Solve both equations. Well, 4 times x, I'm going to divide both sides by 4. That cancels, and x equals 3. I'm going to divide both sides by 4. And x equals negative 3. My two solutions would be x equals positive 3 and x equals negative 3. On example number 3, the absolute value is also already isolated. So now I can just set the expression inside. X plus 2 equals 8. X plus 2 equals negative 8. The most common mistake is that people will just drop the absolute value bars and only set it equal to the positive. But you've got to set it equal to the positive 8 and the negative 8 because both of those numbers are 8 units away from 0 on a number line. To solve this equation, subtract 2, x equals 6. Solve this equation, subtract 2 and subtract 2, x equals negative 10. My two solutions are positive 6 and negative 10. All right, the first three we have looked at already had the absolute value isolated. So your next step was just setting it equal to the positive and the negative of the number. Here on number 4, it's not isolated. I can't break it apart until I can get this absolute value by itself. So this plus 2 on the left needs to go to the right, so I'm going to subtract 2 and subtract 2. So that cancels. And now I have the absolute value of x minus 7 equals 8. Now that the absolute value is by itself, you can break apart the equation into the positive and the negative. X minus 7 equals positive 8. X minus 7 equals negative 8. I'm going to add 7 and add 7. X equals 15. I'm going to add 7 and add 7. And x equals negative 1. X equals 15 and x equals negative 1. On this last example, we also have to isolate the absolute value bars. Here we've got 2 times x minus 3 equals 18. 2 is being multiplied by the absolute value, so the inverse would be to divide by 2. This will cancel, and I have the absolute value of x minus 3 equals 9. Now that I have that absolute value isolated, I'm going to set it equal to the positive and the negative. X minus 3 equals positive 9. X minus 3 equals negative 9. I'm going to add 3 and add 3. I get that x equals 12. I'm going to add 3 and add 3. I get that x equals negative 6. My two solutions are positive 12 and negative 6. Let's look at one more example that I'll just make up. If we have 4 times the absolute value of 2x plus 1 minus 5 equals, oh, I forgot my 1, didn't I? 2x plus 1 equals 15. You've got to get those absolute values by themselves first. So on working on getting this by itself, I'm going to add 5 to both sides. So now I have 4 times the 2x plus 1, the absolute value of 2x plus 1 is equal to 20. And then now I'm going to divide by 4. Absolute value of 2x plus 1 equals 5. Now that that absolute value is isolated, I could break it apart and set it equal to the positive and the negative. So 2x plus 1 equals positive 5. 2x plus 1 equals negative 5. Subtract 1, subtract 1. 2x equals 4. Divide by 2, divide by 2. X equals 2. Over here, I'm going to subtract 1 and subtract 1. Now I get that 2x equals negative 6. Divide by 2. X equals negative 3. So my two solutions there would be +2 and -3. Be very careful that you always have to set the absolute value expression to both the positive and the negative. That's the most common mistake. Every absolute value equation should have two answers. I hope this helps. If you have any questions, please reach out to myself or your Algebra 2 teacher. Hope you have a great day and a great weekend, and we will see you back on Monday.